Okay, this is lecture 7 of my series of lectures on Venn diagrams, propositional logic, and predicate logic. I'm going to give basically a whole course in symbolic logic using Venn diagrams to teach it. So it's a completely new system. Eventually, hopefully, one day, it'll be incorporated into logic books, but right now, it isn't. But one day it should be. Because what I show is Venn diagrams can be used not only for categorical logic, but they can also be used to diagram arguments in propositional logic and predicate logic. Right now this is lecture 7, so I'm still going over the basics. Today I want to focus on P arrow Q. If P, then Q. In many logic books, you'll see P horseshoe Q. Many of you may, if you know anything about propositional logic, you may be familiar with this notation. I'm using the arrow, so I won't be using this, but if you are familiar with this, it's the same thing. This means if P, then Q. If P, then Q. That's the arrow. If P, then Q. And I'm going to show you what this means. To know exactly what this means, it does mean if then in English, but if you really want to know exactly what it means, you have to use a truth table. So let me go over that. So in a truth table, it's going to here. I'll do the truth table first, and I'll explain it. T T F F T F T F F T F. There are, as you see, there are 4 lines. 1, 2, 3, 4. Now, these are all, if you have 2 statements, like let's say today is Monday and it's raining. If today is Monday, then it's raining. Okay. If you have 2 statements, any 2 statements, it doesn't matter what they are. They can either be true. Both of them can be true, right? I say if today is Monday, it's either true or false. It's raining outside, true or false. Well, they could both be true. The first one can be true, the second one false. The first one false, the second one true. Or they can both be false. It's just like if you have 2 pennies and you flip them, heads heads, heads tails, tails heads, tails tails. That's all a truth table does. It gives you all the possible truth values. Truth values. Statements have truth values. That's what propositional logic is concerned with. Statements that have truth values. I mean, the truth values are true or false. If you have 2 statements, there's going to be 4 possibilities. If you have 3 statements, we eventually we'll have P, Q, and R, then we'll have 8 lines. But right now, we're just doing 2 sentences. P arrow Q, if P then Q, is only false for line 2. That's the key thing. It's only false one time. All the other ones, it's true. If I say, if today is Monday, then it's raining. The only time my statement is false is if today is Monday, if that's true and it's not raining. If I say, if it's an animal, if it's a cat, it's in the closet. The only time my statement is false, if it's a cat and it's not in the closet. P arrow Q is only false when the first sentence, first statement is true, and the second one is false. The first statement is called the antecedent, and the second statement is called the consequent. In every other case, it's true. This is called material implication. Material implication. Now, there's been a lot of stuff written about material implication because it kind of sounds kind of weird, like down here, like anytime when you use if P then Q, the if P arrow Q, anytime P is false, the consequent is true. Now, I'll give you an example where that sounds kind of weird. Like, let's say I say, if all animals are cats, which is false, right? If all animals are cats, then I am a billionaire. Now, I am not a billionaire. If all animals are cats, then I am a billionaire. And that is actually considered using the arrow, P arrow Q. If I said if all animals are cats, then I am a billionaire, that statement would be considered true because they're both false. Anytime the P is false, it doesn't matter about the Q. P arrow Q is always true if the antecedent is false. The only time P arrow Q is false is when you have T arrow F. Okay, so I'm not going to get into any more of the philosophical arguments about exactly what all that means. You just have to accept it as if that's how it's used. It's material implication. P arrow Q is only false for line 2 when P is true and Q is false. I said last time, I gave you an example. If I said, let's say I say to you, if today is Monday, I'm going to take you to the park. Let's say the mother says to her daughter, if today is Monday, I'm going to take you to the park. Okay, let's go through it. If today is Monday, mother's talking to her daughter, I'll take you to the park. So today is Monday and she takes her to the park, right? She told the truth. That's what she said. If today is Monday, I'll take you to the park. Let's say today is Monday and she doesn't take the daughter to the park. Then the daughter could say, your statement was false. You said you'd take me to the park. T arrow false is false. Okay, that's common sense. I mean, so that's really what the arrow captures. But let's say I said today, if the mother says, if today is Monday, I'll take you to the park. Let's say today is Friday. Mother said nothing about Friday. So today is Monday is false, right? Because it's Friday. And she takes the girl to the park, true. Well, that statement is considered to be true. It's considered to be true if you think of it this way. The mother never said anything about Friday. She said, if it's Monday, I'll take you to the park. So you could say, well, at least she's not lying. Well, if the only alternative to not lying is telling the truth, then she told the truth. And let's say today is Friday and she didn't take the daughter to the park. The daughter can't say, wow, you lied to me. You didn't take me to the park. But the mother said, well, I said if today is Monday, I'll take you to the park. I didn't say anything about Friday. So the point is if the mother says, if today is Monday, I'll take you to the park. If it's not Monday and it's any other day, Friday or Thursday or Tuesday, then she is not lying. And if she's not lying, she's telling the truth. That's kind of intuitively, you could kind of think of it that way. Anyway, the arrow P arrow Q this is the truth table here. It's for line 2, P arrow Q is false when P is true and Q is false. That's material implication. And here's the Venn diagram for that. Venn diagram, P, Q. Inside the P circle means P is true. Inside the Q circle means Q is true. Outside the P circle, here or here, means P is false. Outside the Q circle, here or here, means Q is false. Okay, now, the 4 lines of the truth table correspond to these 4 sections of the Venn diagram. Section 1 corresponds to line 1 because P is true and Q is true. Section 1, we're inside P and we're inside Q. That means P is true and Q is true. inside P means P is true. Section 2, P is true because we're inside P, and Q is false. We're outside Q. Section 3, P is false because we're outside P. Q is true, we're inside Q. And section 4, P is false and Q is false because we're outside P and we're outside Q. Okay, now I'll take the numbers away because that was just for, for help you to see the connection between this and this. P arrow Q is false only when P is true and Q is false. So I'm going to write P arrow Q. If P then Q, I'll write it at the bottom of the diagram. That means that this diagram is going to be the picture of this statement. It's going to tell you when this statement is true and when it's false. Well, we know it's false only when P is true and Q is false. So we know it's false only when P is true, when we're inside P and outside Q. And to show that it's false, to indicate that the statement is false, as I mentioned in my previous lectures, I'm going to use a dark circle. So I refer to that as darkening the section. So this is the diagram for if P then Q. That's it. And if you want an easy way to think about it, just remember that when you diagram if P then Q, you always darken the section that is inside P and outside Q. It's always the same. Darken the section that is inside P and outside Q. Okay? Okay, now, I'll erase this there now. Now I'm going to show you a diagram, an argument, and I'm going to use if P then Q. The argument will be premise 1. Premise 1 will be if P then Q. Premise 2 is Q and P. If I don't put the 3 dots, anything below the line always means therefore. So this is the premise, conclusion. So here's how you diagram this argument. What you do is you diagram the first 2 premises. We're going to diagram this and see if this follows. If it's a valid argument, if this is true and this is true, this will have to be true. And so let's do it. Let's do this. Well, we just diagrammed. Let me go over here. If P, then Q, Q, P. Okay, if P then Q, I just showed you that's how we do it. If P then Q is false when P is true and Q is false. We diagram Q. Q is true when we're inside Q. When we're outside Q, Q is false. So I darken that and that. That's already been darkened. So now this is the picture here. This is a picture. I've diagrammed these 2 premises on this diagram. So that means that for section 1 and 3, these 2 statements are both true. Now, if I'm going to on a separate diagram, I could do it. I could do it on that one too, but this is the diagram of the premises. So if I'm going to diagram the conclusion, P is true for everything inside P. It's false for here and it's false for here. So you could say this section here, this is the diagram of the premises. This is the diagram of the conclusion. For this section 3, the premises are true and the conclusion is false. So I have T, T, F. In a valid argument, the premises are true, the conclusion has to be true. This is an example here where the premises are true and the conclusion is false. Therefore, this argument is invalid. It's an invalid argument because we have for section 3, true premises and a false conclusion. That's all for now. I'll continue in the next lecture and I'll explain more.